Hello and welcome. Thank you so much for joining me. Today's show is not a debate, although it might look like it's been set up that way. But what this is a conversation. And the way that this show came about was Bill Kluck is a friend of mine from the Atheist and Christian bookstore, book club. And he recently has changed his mind about whether or not a God exists based on the case for fine tuning put on by Luke Barnes. And so after hearing that, it was just a week or two after that Dr. Carrier posted a blog refuting the fine tuning argument and specifically refuting some of the posts, the points of Luke Barnes. And so I thought this would make a really good conversation to bring both of you together to talk about each of your points. So, Bill, let you just introduce yourself briefly and tell us a little bit about yourself.
Well, I was the atheist part of the Atheist Christian Book Club for 6 years. Okay. And just recently, you can see on Creation Today or Hove's thing, I kind of gave my testimony. I really don't have a big time testimony, even as an atheist. Unlike Ken Daniels, who was a missionary to Africa, and you have the former ministers. I was just a regular Christian who became an atheist, and now I don't have a big time atheist. Now Richard would have a huge testimony if he became a theist. So anyway, so that's pretty much it. Yeah, I'd like to play pickleball. Yeah.
Okay, Dr. Carrier, give us just a very brief bio and tell us about your upcoming debate in Nashville.
Yeah. So everything about me, people want to learn stuff more. richardcarrier.info. That's just richardcarrier.info. Has everything.
And I should point out there is a link in the description to that page.
Yeah, the utter destruction of the fine tuning argument is the title of that one. Yeah. So my PhD is in intellectual history, and I'm published both in ancient history. So that's one side of me that people know. But I'm also published in philosophy, like modern contemporary philosophy. So that's another side of me that people know. And sometimes they're different groups and don't know I'm doing the other thing. But this time I'm wearing my philosopher hat, and that's how we ended up here. But yeah, I've been interacting with the fine tuning argument for over a decade now, and in doing a lot of deep dive of the science and the philosophy and things like that. So yeah, I had a lot of thoughts, and we'll see how that plays out. Obviously, today we're not going to cover every angle of this. It's not going to happen. So we're just going to touch the highlights of this, and so yeah, I think it'll be interesting.
Okay, and tell us about your upcoming debate in Nashville.
Yeah, a different philosophical subject, but also my philosopher hat. I am going to debate Andrew Wilson. For those of you who know who that is, you'd be like, oh, really? Yes, I am. I'm going to be taking the side that secular humanism is better for society than Christianity, and he's going to be taking the opposite of that. And there's a blog article on my blog. You go to the same place where I talk about the debate, where you can get tickets and things like that. It'll be in Nashville, Tennessee, early November. And so for that, when you do go to look at the pricing, notice there's a massive list of pricing options. If you go way down there, they're like the cheaper options are in there somewhere. So don't be scared by the whole weekend all benefits price. It's pretty high. But there are more affordable options down below. And then you can just a la carte what you want to come. There are other debates going on that weekend too. So you can check out the link and see who else is debating, what the subjects are and stuff like that. So it's a whole weekend of debates.
That's being hosted by Modern Day Debate, the entire conference?
Yeah.
Okay. All right. I promised Bill Kluck that he could have the floor at the beginning to lay out his case for fine tuning. Go ahead, Bill.
Well, that's a scary thought, isn't it? So I know just enough to make me dangerous, and it'll become apparent pretty soon. But let me just go over a few of the things that convinced me. First of all, the expansion rate of the universe. You have the dark energy driving the cosmological constant that is driving the expansion of the universe, where you have the gravity, the attraction of masses, which are contracting. So this has to be fine-tuned. We used to watch Sean Carroll, who's an atheist, that says within 10 to the 120th. So very precisely this expansion has to happen. Plus, you have the baryogenesis problem where you have matter that creates antimatter, electrons create positrons, quarks, antiquarks. And it's not a given that you'd have more matter than antimatter. So that seems to be a problem. One of the big things that put me over the edge was the strong nuclear force. So in the subatomic world, you have protons and neutrons, and the protons are positive. So they're repelling each other by the electromagnetic force. Now, this electromagnetic force is overcome by the strong nuclear force, which holds these protons and neutrons together and quarks within the protons. So if this is like 100 times stronger than the electromagnetic force and way stronger than the gravitational force. Within these protons and neutrons, you have quarks, 2 up quarks and 1 down quark in a proton, 1 up quark and 2 down quarks in a neutron. So these quarks have positive and negative charges. But if that's not confusing enough, you have gluons which interact with these quarks, which hold them together. They're force carriers, carriers that, hold these things. So I was thinking, where does this strong nuclear force come from? And let me tell you, if this thing is like 2% stronger, you get the periodic table, but you don't get hydrogen, which is kind of important since it's all over the place, 75% of the universe, and is important for things like water and so forth. If it's 5% weaker, then you only get hydrogen, lonely protons, hydrogen protons, electrons bumping into each other. And obviously without carbon and other things in the periodic table, you don't get us. You don't get a life-permitting universe. So that was the problem. Now, also, carbon, the creation of carbon in nucleosynthesis in the stars is a major miracle because you have 2 helium nuclei that combine with 2 other helium nuclei, and they form helium-4. Now, beryllium-8. Now, once you get beryllium-8, you've got to find a lonely helium nuclei again that will then form carbon. The problem is beryllium-8 only lasts a fraction of a second. So that has, its problems. So also the thing that got me was the Pauli exclusionary principle, first stated by Wolfgang Pauli, where you can't have 2 electrons with the same quantum number occupying an orbital. And they have the 2-8-18 rule where you'll have 2 in the first K level, then 8, then 18. So why in the world do you have these levels and orbits and these very specific things that have to go right to have chemistry? Because these electrons obviously combine with other electrons to form molecules and so forth. The other thing is the constants, the gravitational constant, fine-tuned to 10 to the 40th, the Planck constant, speed of light, and the fine structure constant, which is 1/137th, which Richard Feynman said every physicist should put this number on a board and worry. And if it's off by like 4%, then you don't get chemistry, and thus you don't get carbon or whatever. So one of my questions to Richard will be, are you worried about this fine structure constant of 1/137th that appears all over physics and so forth? So finally, to wrap it up, if you start with a mind, everything seems to fall into place. But if you start with matter, you're going to lose your mind. That's it.
Okay, very good. Richard, the floor is yours.
Okay, cool. Let's see. So you know what I'm going to do? I'm just going to run through the points that he made just now. But then I want to dive into the other side of this story. So there's a whole other side of this. And I think that this is a thing with Christian apologetics generally, and I think Luke Barnes does this, is they're leaving a lot of evidence out that when you put it back in, completely changes how things look. And so You can make things look amazing if you skip a bunch of stuff. And so I'll get to that. But just very quickly as we go through those points, some of the problem with the fine-tuning argument is that there's a lot of confusion. And I'm not going to go into whether Luke Barnes is causing this confusion deliberately or not, but there's a confusion. So like the Sean Carroll video is a good example where he confuses in the video two different things, which is the cosmological constant and Penrose's entropy calculation. And these are unrelated. I don't want to get into the weeds on that, but that 10 to the 120 power thing is not a fine-tuning thing. It actually isn't a constant. It doesn't factor in here. The cosmological constant thing where that 120 comes from, it's actually 10 to the power of 10 to the power of 120. And that's the measure of theory error. It's the measure of the error of quantum mechanics. Because quantum mechanics generated a prediction and it's wrong by that much, which means to scientists, that means that the theory is wrong. So it doesn't mean that anything, it's like God did not tune the universe to match our theories. No, our theories are just wrong. And we know that already. We knew quantum mechanics and relativity theory contradict each other. So one of them or both of them is wrong. So we know there's something wrong. So that doesn't have anything to do with habitability. When people talk about the cosmological constant, it can actually vary by many orders of magnitude and still have a habitable universe. It can also just not exist. And there's actually a lot of science out there lately that is questioning whether it even exists, that there is any dark energy. So there's a lot of questions with that. Maybe we'll get into more into that in the discussion later. But those things, that's actually not, this is a common thing that people will use this as an argument in fine-tuning. It's actually not an example of fine-tuning when you start getting into the weeds of where these numbers actually come from and what they're actually measuring. Now, more interesting is getting into the strong force question. So there's actually way more questions that have to do with habitability like this. So the fine-tuning argument is focusing on how does this affect habitability, but physicists are more interested on why is it crazily like this at all? And for those of you who might be interested in this, there's a really great speech about this, a psychic speech, because it's clairvoyant, because it came out like 150 years ago. But it's Robert Ingersoll did this speech, and he has a whole analogy in it called the fabulous carriage. So if you Google Robert Ingersoll fabulous carriage, you'll find this. And it's as an orator, it's really well stated. But he basically describes this outrageously complicated, ridiculous sounding carriage that carry people around in. And he asks you, does that sound intelligently designed, or does that sound like random chaos, really, right? It's like, why would it be so complicated? And we look at the strong force, for example, and that whole complicated story that he just told. Why is it even like that? God doesn't need to do any of that. Like, God doesn't need quarks. Like, he doesn't need gluons. He doesn't need the strong force. Why is any of that there? God is actually a bad explanation of all of that. And this is why that theory is not popular. In fact, God as a theory is not a past peer-reviewed cosmological theory in the sciences, because physicists think there's got to be a better explanation for that than just a lunatic designed it. God wouldn't need to do that. God would just make elements and he wouldn't even need the atomic structure. He would just make water act like water and earth like earth and so on. God has way more options than this. So this looks like a crazy lunatic or something that was jumbled together at random, right? So it doesn't look intelligent. Its complexity is actually evidence against its intelligence. It's way too elaborate. It's like if you went into a corporation and they had the most ridiculous administrative procedures and you say, like, an intelligent person did not design this, right? An intelligent person would come up with something more efficient. So when you're looking at actually how do we measure like the effects or expected evidence of intelligences versus chaos, randomness, and so on, really needlessly complicated systems are evidence of non-intelligence. So there's nothing intelligent doing it. Something else much more random and chaotic is explaining this. And the same goes for all the others. And so when physicists deal with these things, they're looking at things like superstring theory, holographic cosmology. Like they have actual working theories that explain a lot of these things. And so those show much more promise. Like they're actually solving a lot of other problems in physics. They're actually having promising ideas. Like just recently, they came out with some studies where you can start to predict the masses of the quarks, for example. So that's making progress, whereas the God theory has nothing to offer in terms of predictability. It can't predict the mass of the top quark. It can't even predict that there would be a quark, right? So a working theory that would actually be successful should predict why there are quarks, right? It should explain that. And when you look at all the theories that do that, none of them involve God, right? So like the field of physics, the physicists themselves are like, they know what they're doing. They're not interested in this God theory. It's a bad theory. And so what they're doing is they're looking for much more fundamental explanations for this stuff. And they usually end up in geometry. Maybe this will come up more later, but I think geometry explains almost all of this, if not all of this. One of the examples is the fine structure constant. That's an unusual one because it's the only constant that is unitless, right? And it's looks like it could be an irrational number. And what does that look like? That looks like, and you look at a lot of equations, they have pi. Pi shows up in a lot of equations. What is pi? Well, that's a geometric, that measures the geometry, right? So that means a lot of the laws of physics are coming out of geometry. So I strongly suspect that the alpha constant is going to be something geometrical. It'll probably fall out of something like superstring theory or holographic cosmology. And it probably can't be tuned. And this is one of the points that I'll get to later, which is that the problem with the fine-tuning argument is we actually don't know any of the things that we need to know to get the conclusion. We actually don't know what causes the alpha constant. We don't know that it can be tuned. We don't know what the probabilities of the distribution of the different values it can have. We don't know if it's perfectly random. We don't know if it's a bell curve. We don't know what, or anything. We also don't know if we change alpha, what else changes? Do we change the mass of the top quark and so on? So we actually can't do the math that we need to figure out what kinds of universes can exist, right? We're not even there yet. So you can't actually make this argument that most of them would be uninhabitable. We don't know how to do that. We don't know the physics for that. We don't know the math for it either. Maybe we won't get into the math because the math is this gets to the McGrews and so forth. But and their point about this. But
so you're not worried about the fine structure constant, okay?
No, no. So that, to me, that's a great clue. And I'm with physicists on this. It's like that tells us there's something geometrical going on, and we just have to find it. So rather than thinking that it's some sort of magical dial that a ghost turns that decides what it is, magically decides what it is, there's got to be some sort of underlying physics that entails what it is. And an example of this is the boiling point of water. We used to think that was a fundamental constant that was tunable and it was perfectly tuned, etc. But it turns out now that we know from quantum mechanics why it is what it is, that it can't be changed. Once you get all the underlying physics, the boiling point of water is an automatic outcome of that. It can't be tuned. And so alpha is almost certainly going to be like that. And I think in reality, when you look at all the constants throughout the last like 200-300 years, what physicists have seen is that time after time after time, they've had an explanation. They found that it's caused by something else and can't be tuned. Huge amounts of these constants have been explained. And so we're down to just the few left over that are called free parameters, that are the fundamental constants. And the only reason we don't know what's underlying them is that we need like instruments larger than the Earth and things like that to get at this, right? To get the particle accelerators of the size we need to explore this kind of structure. We would need something that would, wrap around the sun or something like that. This is thousands of years away. That we're not going to have the experimental ability to get at it. Scientists are getting clever, though. They're coming up with clever ways around this problem. But the point being is that the reason that these fundamental constants are left over is that that's the fringe, the frontier of the science. We're still getting there. But if you look at the trend line, this is what physicists like, it's trend lines. It's always been explained before. It's always been a natural explanation for why certain numerical values turn out to be what they are. And so they're pretty confident that all the rest of them, like the mass of the top quark, the strength of the strong force, all of this stuff is going to fall out of some more fundamental theory. Like all the trend line evidence points in that direction. And the most productive, like the most fruitful theories that have actually generated a lot of interesting knowledge and so forth have come out of assuming that. So we know there's a lot of clues that that's the way to go. But when it comes down to like trying to make an argument, we just don't know. Like we could no more prove right now that God exists using the fine-tuning argument than we could prove superstring theory is true. And yet superstring theory would explain everything and without a God, right? But we don't know that that's true. I mean, we're exploring it. It's a theory. So right now we're just not in a position to do that.
What is superstring theory?
So superstring theory, actually, you could do a whole show on that. But to keep it simple, superstring theory posits that everything like photons, gluons, and therefore the strong force, everything are vibrating strings, or you can actually say that it's just vibrating space-time itself, that these are waves in space-time, but through multiple dimensions, so that we have what's called a Calabi-Yau space, which is a super small dimensions that are curved in on each other that we live in all the time, but they're too small. We don't see them. So if you have like 11 of these or 10 of these or 7 or whatever, you add that into the 3 dimensions of space and the 1 dimension of time that we have, that you can end up predicting all the forces and all of the things like that, and explaining why. And then you can unify quantum mechanics and relativity. And it accomplishes a lot of things. And so that's why one of the leading, most promising things. There are other theories that cover other parts of this that aren't reliant on superstring theory, like holographic cosmology. And there's just a ton of stuff. If you go to Wikipedia and look for a theory of everything, they'll kind of give you a breakdown on what's going on. Because what we're talking about is that it's a theory of everything. If you just limit it to explaining things like the strength of the strong force, it's called a grand unified theory. So like we've explained all the forces, almost everything about the forces up to a certain point. Unifying gravity is the final step. Once we do that, that might actually result in understanding why does the strong force come out at that strength? Because all the forces were one force at one point. When that universe is super hot, it's only one force. And then when it cools, it breaks into these multiple forces. So the question is, does it break at random, or are there laws of physics that dictate where they break? Right? And so that we don't know that, right? So this is the thing, is that we don't know these things, and therefore we can't get, if your premises are unknown, your conclusion can't be unknown. And so that's the fundamental problem that I find with.
But speaking of these forces coming into existence, you have the gravitational force coming into existence, and then the electroweak force, which leads to the strong nuclear force in the electro. I mean, doesn't that just seem to be, how does that happen just by random? That's the whole problem I'm having, is the random.
Yeah, right. I mean, what the problem you're having is that we don't know, right? Like this. So I'm emphasizing that we don't know the answer to this. So we can't leap to conclusions. We can no more leap to God than we can just assume superstring theory is true, because it also explains everything, right? So we could do it with just as well with superstring theory as you could do it with God, just arbitrarily doing it. So we're at a state of ignorance, but there's a bigger problem. And I could go further, like we go on and on about like why I think we can't establish the premises. It's not that they're false, it's that we don't know that they're true, and so you don't know the conclusion is true. And that's the fundamental problem with the fine-tuning argument. But there's an even bigger problem, which is that, as I mentioned before, like God wouldn't need quarks, right? Like just like God doesn't need a starship, for Star Trek fans who know that line. What need does God have of a starship, which comes from Star Trek 5? God doesn't need quarks, right? So God doesn't need anything. God doesn't need fine tuning, right? Because you got to think in terms, he doesn't need to tune a force. Why does he need to delicately tune this weird, obscure, strong force when he could just make the universe work the way he wants, right? And this creates a probabilistic, like a logical probabilistic problem that actually makes the fine tuning argument reverse into an argument against God. And can I show my screen? I think I can do that, right? That's let's see, image file, slides in PDF. Oh, I haven't loaded.
But these constants, like the gravitational constant, fine-tuned to 10 to the 40, these numbers are just mind-blowing, aren't they? I mean, just
there we go.
The preciseness of these things.
Well, so first of all, there's a million of these things, right? So a lot of them don't even have to be that precise. Secondly, we don't know what the relationship. We don't know what the relationship is. So there's a problem in statistics called autocorrelation, and when you where you measure a variable against itself, and it looks like you have this amazing, like specific, super precise correlation, but really you've just been measuring itself the whole time. So like if, for instance, the alpha constant dictates the strength of all the forces. We don't know this, but let's just say it did. So such that anything you did, like say maybe it's something to do with the size of the Calabi-Yau spaces. And so you change that, but it changes everything else. And consequently, there's no way you can tune it that would make it any different. And this is what we get with like the speed of light in holographic theory, is that in holographic cosmology, there's no other value for the speed of light that you can get to, because it's just measuring a percentage. So when you're at 1, you're at 100% of the speed, and then everything else is a percentage of the speed. And so we see the clue in this when we use natural units, when we use Planck's constant to define length and distance. And let's see, can I window?
That leads me to a question. We use mathematics to describe these laws of nature and the universe itself. Isn't that kind of surprising to you that we could understand by mathematics the universe? I mean, what's the chances that that would happen?
Yeah, that's a different question. So like that would be a different show.
Okay.
I have an article on that too. It's called "All Godless Universes Are Mathematical" that people can find on my blog.
I'm glad you brought this one up because I read this on your blog and I did not understand it.
Yeah, it's basically that. So one good philosophical tool when you run into things like this is to ask yourself, how could it be otherwise? Like, what would you have to do to make a universe that didn't obey mathematics, right? And when you actually start thinking about this, you realize you can't do it. It's logically impossible to have a universe that isn't described by mathematics. And it comes down to the fact that mathematics is just a way of measuring ratios, quantities, basically just ratios and quantities, mostly like geometries and so on. So that you can't have a universe that doesn't obey these certain laws. And a classic example is inverse square laws. Those follow necessarily from propagation in three-dimensional space. It's an inevitable, unavoidable outcome of geometry. So everything's inverse square. Even the strong force, contrary to what a lot of people think, it gets stronger over distance. That's not actually true. It follows inverse square rules. Yeah, it actually follows. It actually gets weaker. It follows the same rule. Yeah, it does. It follows the same inverse square rule. The reason that it has the effect of looking stronger is that it requires so much energy to pull against the strong force that it actually generates more gluons that generate more force. So it's like if like trying to pull magnets apart, you started creating electrons. And so that the magnets get, are pulling harder and harder because you're multiplying electrons. But each electron, the force is dissipating at the same rate. It's still dissipating over distance as like anything, but you're multiplying the electrons. So you're actually increasing the amount of force, not the strength of the force. This is how the strong force works. That's why it does that weird thing that it gets stronger over distance. Yeah. In fact, if you pull it further and further, eventually it just creates a whole new quark. And then the quark, snaps to all the, so you can't actually get to a point. Like it's like you're trying to pull magnets together and then another magnet shows up in the middle and collapses your whole high school project. Right. So it's that kind of thing. This stuff is really weird. Obviously. And physicists see this as clues to something being an underlying explanation. It's very similar to mind-brain physicalism, where we see how the brain works is so kludgy and weird and convoluted that it obviously has physical basis, right? Because you can tell that it's some sort of complicated physical apparatus. You can tinker with it and it messes up all kinds of other things. And so the complexity of the brain is actually evidence of mind-brain physicalism. It's not evidence that God made it. In fact, it's evidence against God making it, because God would make a better brain than that. And so anyway, that's a digression on those other things, but that gets to the idea of that. So let me bring something else in. So I'm going to kind of like change the subject a bit. So I'm going to pull this in. Let's see if this works. I see a. Is everybody still there?
Yeah.
Yeah.
Is it me? No.
Did you have a different slide you wanted us to bring up? Because I'm still seeing the same one, I think. Oh, it's not bringing it up this time.
No, we've frozen.
Okay. All right, Dr. Carrier is frozen. So Bill, while we are waiting for his Wi-Fi to reconnect, what do you think so far?
I don't know what happened there. It disappeared.
Yeah, your video froze up and then you rejoined the stage. So I just switched out which presentation you were.
Okay. Maybe I can't do this then. Let's see.
You should be able to, because I'm actually showing another.
Maybe you have to pick it.
Well, I have to put it on the stage, but you have to put it up there for me to pull it up.
Okay, so the question is, where is that button? Where do I find that?
At the bottom of the screen, there should be a present or invite button.
I see.
And you should be able to put your slide on there.
I did, and it's showing on my side next to my window. Yeah, okay, maybe this is just not going to work. All right, let me just do something different here. So I'm going to drop in the comments for those who are watching the link to it, since I can't get it in here.
Okay.
So it's in public comments. I'll throw it in private chat if you need it closer to hand. So what I've done on this page, and it's not terribly necessary that people look at the page. It's just people might be curious to see it. But it starts at the top with an actual formal proof that fine-tuning proves, fine-tuning is evidence against God. It doesn't prove anything, but it is actually evidence against God, not for God. And the reason is that due to the probability of a thing is determined by its prior probability times the likelihood ratio based on the evidence. Oh, there it is. Yay.
Yeah, we had this up before.
Okay. Oh, okay. It wasn't showing on my side. So I guess that's why it wasn't showing it to me and I was confused. All right.
Okay.
Yeah. Okay. Very good. Yeah, that's it. So that's the thing. No, so what you get here is you have the prior probability of naturalism is greater than the prior probability of God, and the probability of observing fine-tuning given naturalism is greater than the probability of observing fine-tuning given God. And so the rest follows. So once that's the case, it becomes necessarily the case that fine-tuning is evidence for naturalism. Naturalism is more probable given fine-tuning. That's line C there. So the probability of naturalism given fine-tuning is greater than the probability of God given fine-tuning. And the reason is because of the two things. So the prior probability, I mentioned already the idea of background evidence. So naturalism is backed by all precedent and God is backed by none. So this is the evidential aspect of the prior probability. All past evidence has confirmed natural explanations over supernatural. Therefore, the supernatural has never explained anything before. It is therefore unlikely to now. So already we have the prior trend is it's going to be something natural more likely. We don't know what it is yet, but it's probably more likely going to be a natural thing. But there's also a logical problem with the prior, which is that naturalism requires fewer suppositions and less tuning than God. So proposing God is actually proposing that you're getting super lucky. Like God is more lucky to have than fine tuning. It's actually the amount of like astounding luck you would have to have for there to even be a God, as opposed to just even single universe fine tuning. Even before we get to multiverse theory, which is a whole other problem. And that's because God requires infinite specified complexity. So God is actually the most theoretically complex entity that you could propose compared to like quantum cosmologies, which require just a few simple assumptions of very minimal complexity. So there are much simpler theories than the God theory. And the way to think about this is you compare a worm's brain to a human brain to a God brain, you can see the scale of complexity goes up, right? So like worm is if you could explain the universe by the behavior of a worm, you've explained it much more simply than with a God, because God is a massively more complex entity. And the same thing goes with like the physics. So you can say like the simplest quantum vacuum, you can compare that to a convenient collection of spontaneous superpowers, right? So like I think the hidden fallacy in the fine-tuning argument is just assuming that you can just park all the improbability in God and it goes away. But really all they're doing is you're moving the improbability from the chance accident of fine-tuning and you're burying it into this God character. But all you've done is move the improbability around. So you haven't really determined which piece of luck we got. Did we get a lucky God or did we get lucky fine-tuning through a natural effect? And so, and there's no way to calculate this. So we can't even show that God is more likely than any other natural explanation of fine-tuning. So the prior probability, God is actually more complex than most natural godless theories of fine-tuning. So given both of those things.
Before you go any further, we have a couple of questions from Daniel Ray that I'd like to go ahead and take, which is, he asks, how does Richard know what God is like? And along those same lines, from what source is Richard deriving God's characteristics? Yeah,
so the God theory in the context of fine-tuning, so I assume we are not allowing aliens in another universe to be counted as God, right? We're not saying that just moves the problem to another universe that we have to explain. So if you're trying to explain the creation of a universe, now you have certain necessary parameters for God. God has to have certain things. So he has to be super intelligent, right? He can't be an idiot. He's got to be super powerful. He can't just be as weak as, just some random alien somewhere. And so there's these things that are entailed about God that you cannot abandon and still have the theory work. And those things require positing massively coincidental chance accidents. Like how do you just by chance accident have this amazing disembodied superpowered mind that's just perfect and does all of this other stuff. That's super lucky, right? And we don't even know how to calculate the luck of that, right? So we don't even know how to get a thing like that. We're not even really sure that you can have a thing like that. It might even be logically impossible. We don't know. And so this is why usually the fine-tuning argument usually has a hidden premise in it, which is really the ontological argument, which is Christians want to argue that God is logically necessary because that would solve this super improbability problem of God. But no ontological arguments work. So there's no evidence that God is a necessary being. So we're stuck with chance accident. And so we're just lucky. We're just lucky that we have this incredibly wild, amazingly powerful, amazingly intelligent, strange mind that just happens to be disembodied and capable of doing all of this stuff and desires to do it anyway, etc. So yeah, that's luck. So this is the incommensurability part of the premise. So we do not know which is more lucky, the God or the fine-tuning, especially when we add all the possible ways to get fine-tuning without God, multiverse theories like eternal inflation and so on. So there's a lot of different ways to get fine-tuning out of naturalism that don't require the extreme improbabilities that the God theory requires. And then we have the precedent. So we're adding these two things. That's a logical problem. The evidential problem is all precedents show that constants are always explained. Every time before, they've been explained by something more fundamental. They weren't tuned by a deity or anything else like that. They weren't tuned at all. They're just an inevitable outcome of physics. And if that's been the case every time before, we're pretty confident it's going to keep going that way. And we would need evidence that it wouldn't, right? You can't just assume that it won't. That gets you an unknown premise, which gets you an unknown conclusion. So that's why the fine-tuning argument can't carry. You can't carry the argument because you don't know the things you need to know to carry the argument. So anyway, so this gets to the priors. So the priors favor naturalism, both logically and evidentially. And so that leaves the likelihoods. Now, here's where this point I was making earlier comes in. God doesn't need fine-tuning, right? God can just make a universe. He doesn't need the strong forces, need quarks. He doesn't need any of that stuff. He also doesn't need random biogenesis. He doesn't need DNA. He doesn't need to start life as a single cell and wait around for billions of years for it to become a multi-celled animal. Like, he doesn't have to do any of those things. However, if there is no God, then the only way we could be observing ourselves here is if those things were the case. So this is the problem, that if God doesn't exist, then the probability that we human beings would observe fine-tuning is 100%, because the probability is 0% that we would exist otherwise, right? So there's no possibility of finding ourselves in a non-finely tuned universe unless it was built by a God. So in fact, the probability is greater that if God existed, we wouldn't have fine-tuning. We would have a God-made universe. It would be like divinely ordered, just like you see in Genesis 1-3 or something like that, or in Aristotle's universe. Like, Aristotle's universe is very God-centric in a different way. It's not in the same way as Christian theism, but it's still supposed to be very elegantly designed and inhabited through every component of it, all the way to the stars and so on. But we don't observe that. We observe the opposite of that. So, and I go into this in the other article. I don't want to get into the weeds on this. We can give examples. But basically, because fine-tuning, the probability of observing fine-tuning, once you assume that naturalism has caused it, is 100%. But the probability of assuming fine-tuning, given that God has created everything, is less than 100%. So that means that the likelihood ratio always favors naturalism. So, and this, I didn't come up with this. I independently did suspect it, but then I found a lot of other researchers have proved this. Sobel and who's the other? Jeffries and Ikeda and other philosophers. There's several papers on this showing this.
Okay, before you go on, Bill,
yeah.
Does this make sense? Do you have any questions about this? Do you have any pushback on this? Bill, you're muted.
Still
Bill?
muted? Yeah, I show muted.
Yeah. Bill, can you unmute yourself? Because you're not muted from my end.
Okay, can you hear me now?
Yeah.
Yeah.
So if matter is the thing that creates everything, you're familiar with Roger Penrose's cyclical conformal universe and bouncing universes and so forth.
Yeah,
Go ahead.
I'm not a big fan of Penrose's theory, but I understand the model.
Which one do you like of
Penrose?
Of any of the ones where you don't? Do you believe in the Big Bang?
Yeah, well, eternal inflation, which
Okay.
just puts me in the majority consensus already.
But matter isn't eternal.
I do strongly suspect it's going. The black hole cosmological, black hole holography and cosmology is very promising to me. I think that's going to turn out to be probably the thing eventually. But that's not mutually incompatible with eternal inflation. You could actually come with a hybrid model.
What's funny, we had Dr. Sarah Salinger, who became a Christian because of black holes. She's a PhD physicist, but she felt that led her to believing in God. So it's funny how we all look at the same evidence and come to different conclusions. But matter decays and deteriorates, where God, being eternal, doesn't do that. I mean, does that make sense? That
that remark's a little muddled. I'm sure someone could steelman it more. The primary problem is that matter didn't exist originally. So matter is a late product of the universe. It was all the Big Bang was mostly other stuff. Like actual matter, like that actually comes out when the universe cools. It's not something that started in the beginning. And so, but that's what they get to, like the inflaton. So you just have one single wave function that results in that, expansion and cooling that sort of results in what's called symmetry breaking, which results in, the dissipation of matter, just like in the form of dissipating dew, in the morning or whatever, right? So it's the exact physics of it gets us back to that question of fundamental theory, which we're not at. So like superstring theory has one way of doing it. There are other theories of everything that have other ways of doing it. So there's various godless ways to do it. But right now we don't know which one is correct, or if it's something completely different than what we know or whatever. But if just the question is, we can't get to God that way because we can't rule out these other things, right? So we don't know which it is. So which lucky outcome is it? When we're looking at the actual models that we're seeing in peer-reviewed journals, they are theoretically simpler than the God theory, and they have much more background precedent in the evidence and what we've seen before. So they actually stand with a higher prior probability. Even if it's a low prior, it's still way higher than God. God is still even lower prior probability because he has none of the epistemic advantages that those theories do. But the other problem is this fact that you can't not see fine-tuning if God doesn't exist. So fine-tuning is a logically necessary thing. If you're observing yourself and naturalism is true, you always will view some sort of fine-tuning. Whereas that's not the case for God. And so logically, fine-tuning evinces the absence of God. And this gets back to the point I was making earlier. Fine-tuning requires bizarrely convoluted, unintelligent ways of producing life. Whereas if you could just produce life, like we could do, if we get to the point where we can have people living in virtual worlds, where we can just program those worlds, we would find it be extremely inefficient to program them all the way down to quarks. That would be a really dumb way to do it. And it won't be how we do it at all. We will make it much simpler. It'll be more like Tron, for example, or a Miyazaki film or something like that. The physics will be much simpler and more elegant, and won't have this underlying complexity that makes it look, totally lunacy.
Well, isn't it amazing that it is when at the bottom of the standard model of particle physics is quarks and electrons and, the other things like gluons. Isn't the simplicity point to God?
Not simple. That's not simple at all, first of all. So there's no simplicity there.
Quarks and electrons?
The question is, the quark theory is not simple. If people go to Wikipedia, look at standard
at the very bottom, we have quarks. We don't that make up protons, neutrons.
But so people need to Google something like how do quarks explain atoms? It's insane. Like the massively convoluted, complicated way that quarks generate just a proton when you could just have a proton. Like it's insane. Like it's really like lunacy. I'm serious. Like you look at it, like no intelligent person would build a universe that way. But the question really, you're saying amazing. The question is, what's more amazing? Like they're all amazing. All options are amazing. So the question is, what's more amazing? That we have a disembodied superhero, or that we have something like, eternal inflation with an inflaton field that explains it all, or that a superstring theory or something like that, which is actually more amazing. And that's what I'm looking at these metrics in terms of theoretical complexity. The natural models are much, much less complex. You have to assume far less. You don't have to assume superpowers. You don't have to assume a mind. You don't have to assume intelligence. You can get a lot of effects out of randomness, basically. And then the other is evidential. So we have all of the precedent here. So what would be more amazing would be to suddenly discover the supernatural when all the other like times we opened the door and looked at what was inside, every single other time it was naturalism. So supernaturalism would be surprising. So it would be more amazing if it had that explanation. So whatever the explanation turns out to be, it will always be amazing. That's absolutely sure. Our question here, when we're trying to use the philosophical argument, the fine-tuning argument, is what's more amazing. And that's when you have to get into the metrics of how do you measure relative amazingness. And in terms of theory, that's what this paper that I had put up before. People have the link now. Hopefully they can go look at it. Now, mind you, that's just a super brief. If you really want the detail, that's the article that's linked below.
But just kind of, this is kind of incredulity, but you have 100 billion galaxies with 200 billion stars in each galaxy. They've said there's as many stars in the universe as there are grains of sand in all the beaches of the world. I mean, doesn't that give you pause?
I'm glad you brought that up, because that's actually more evidence against God. So here's the thing. If God does not exist, right? So let's just posit for a moment that it is a natural cause, whatever it turns out to be. If that's the case, then the only way life could arise, it would have to be a highly complex and therefore highly improbable accident for life to get started, right? Biogenesis, whatever the probability is, it's very, very low.
Right.
So probabilistically, you can do the math actually and determine, like, probabilistically to near 100%, if we're here and God does not exist, then what we should expect to observe is an extremely old, extremely large universe full of an extremely large amount of stuff, because only in an extremely large set of trials would an accident like that be probable, because it's a theory of total probability. So what is the probability of that? If there was just one planet, it would be astronomically low. But if there's billions and trillions of planets, then the probability actually approaches 100%, right? Because you're playing a lottery billions of times. The odds that you're going to win are, approach 100%. But if you play it only one time, it's, 1 billion to 1 or 1 million to 1 or whatever. So we can predict this. So we can say that if there's no God, we should predict that there should be billions upon billions of galaxies, or really trillions upon trillions. Conversely, God doesn't need a universe that is 99.9999% lethal radiation-filled vacuum. 99.999% of the stuff that's not lethal radiation-filled vacuum is stars and black holes on which no life can live. And then of everything that's not either of those things, 99.9999 whatever percent of all the matter, the other stuff that's not stars and black holes, is uninhabitable, right? So like if you squeeze the whole universe into a house and you walked into that house, the entire house would be lethal to life. It would be not at all designed for life. And the amount of it that would harbor life would be smaller than an atom. It would be like the size of it would be that small. Right. So, and that does not suggest, and it would be that small. It would be, and we can prove that all of the things there are chance accidents. So like where the Earth is a chance accident. The way we were bombarded by comets on the early Earth, chance accident, and so on. So you can show that it's just luck, right? Like you see a million lotteries played. You're going to see some winners because there's so many lotteries being played. So the evidence really shows that it was just luck, right? That got us that. That's what we expect to see if there's no God. God doesn't need that. God could make the entire universe habitable, which is exactly how the early biblical authors understood it. It's how Aristotle understood it. Why would you have this lethality? Why would you even have black holes? Why would you need galaxies? Why would you need stellar evolution? You could just make Earth. You don't need this complex process to build carbon. God doesn't need that any more than he needs a starship to get around.
So
right?
You think there is a God? It's overkill to have all these stars and galaxies. And
why? So what's your metric on overkill, right? Since there's no intelligence.
100 billion galaxies.
Yeah, but there's no. So when you say overkill, you're thinking in terms of an intentional agent. But on the supposition that there's no God, there is no intentional agent, right? So no one is selecting for an efficient universe. That's my point, right? It's like we should expect to see a massively inefficient universe if there's no God, right? We should, if it is an intelligent engineer, it should be a massively efficient universe, right? It should be super efficient. There should be breathable air all the way to the stars, right? Like every planet should be inhabitable and have life on it and so on. Or there wouldn't even need to be any of that. You could just have the solar system, or you could just have Earth, or whatever.
But could you make the argument that Hugh Ross does, that the book, The Rare Earth, that the Earth is special as compared to the rest of the universe? I mean,
okay, so you're talking about Brownlee's book, right? Rare Earth. Because
Hugh Ross is, this amazing Earth.
Let's not confuse Hugh Ross with Brownlee. Okay. So Ross did not write rare earth. Ross misquotes.
I know, but
Ross misquotes rare earth. But no, the actual authors of rare earth, their point was my point, which was that simple life should be common, well, relatively speaking, whereas complex life would be less common because the number of chance accidents you need to get complex life means it's going to be rarer, which is absolutely correct, right? Definitely the case. But the whole premise is based on the assumption that there's no intelligent engineer choosing that there should be this outcome, right? So they're assuming that it's chance accident. Their argument only makes sense if you assume it's chance accident. And that's why, in fact, this is what chance accident predicts, that you should predict to see a huge, vast, wasted universe of all these failed experiments. That's not the sign of intelligence. That's the sign of the absence of intelligence. Like the only way you can get life without intelligent design is exactly the kind of universe that we're staring at, which is a really weird coincidence. Like why would God make the universe look exactly like the universe would have to look if there was no God, right? Like that. I mean, unless his intention was literally to fool you into thinking he didn't exist. But then God would agree with me that the fine-tuning argument argues against his existence, and that's why he left all this evidence that he doesn't exist to trick you into thinking he did. But obviously that didn't work, so you've been tricked into thinking he does exist by all of that. But the Brownlee point in rare earth is my point, is the point I'm making now, is that that's what we expect without a God, and that's exactly what we observe. And it's really weird if there is a God. That's not what we should observe if there was a God. So that's why the likelihood ratio of the fine-tuning argument pushes towards naturalism and away from theism.
Mm-hmm. Well, as a newborn theist, I do have problems like 3.5 billion years ago, you have the first prokaryotic cell, and it takes 1 billion years to form a eukaryote. Is God just thinking,
yeah,
I wish I could solve this? I mean, if there was only, a nucleus. I mean,
yeah,
but
right.
God's not on a timetable. And, I mean, do you see like the origin of life, that the DNA enigma? I know they've shown some multicellularity coming about randomly, and the chirality problem that all the amino acids have to be left-handed have been somewhat solved. But still, you've got such a hurdle to get to. Like the DNA, it's not the chemical makeup; it's the information in the DNA.
Right. So for the audience's sake, like if this is drifting away from the fine-tuning argument, so we're getting into biogenesis argument, which is different from the evolution argument, right? So those are whole other things. DNA is actually an evolved machinery. It's not, life didn't begin with DNA. It either began with RNA or more likely DNA. More likely PNA, actually. The PNA first, the metabolism first hypothesis is much simpler and has a much higher probability of generating, getting it started. But that's, we don't need to worry about that here. The question you asked is the apt one, though, is you see this weird effect, right? Absurd amount of time to come up with a nucleus or whatever, right? Mitochondria are like crucial, right? Why did it take so long to come up with that, right? And we have evidence that mitochondria joining cells was an accident. It's a parasite that just started living there, right? And so you can explain it in terms of the absence of intelligence, and so the question is, if you want to explain it with the presence of intelligence, now you're putting a great deal more weight on your theory, because how is it going to predict this extremely weird observation? Because this is not naturally what comes out of an intelligent engineer did it, right? So you have to make the theory much, much more complicated to come up with these convoluted reasons for why God would make it look exactly like it would have to look if there was no God doing it, which is strange, right? And strange means improbable, and so that's why you get the proof that I showed you earlier, that there's no way around this. Fine-tuning is always what you expect on naturalism, is hardly ever what you expect on God. And so it's actually evidence the other way around. And so things like your observation there, it's like the theory should be able to explain the strange observations like that, not have to have them explained away, right? So if you have to explain them away, your theory is a bad theory. But if your theory automatically explains that, it predicts exactly that, then that's what we should expect to see. And that's exactly an example of how naturalism predicts. That's what we should see, is something like that, a long, arduous trial and error process that results in building over time. And I have an article on this called the Wong-Hausen proposal. People can check that out, where a crucial component of this is random interactions, but something sticks around. So stellar evolution is an example of that, where it's not just random chaos, that it's random, but it leaves stuff in its wake. It's like so you can ascend levels of complexity because some of the junk is left over that's more complex than the stuff that started. You end up with carbon hanging around, not just helium,
Yeah,
right? That
yeah.
kind of thing. But that's exactly what you expect for a godless universe. It's, if we are ever to find ourselves in a godless universe, it has to be a universe that works that way. And so that's what we expect from a godless universe. And so the question is, like, does God need to do that? Does God need billions of years of stellar evolution to make carbon? Can't he just make carbon? Why does he even need carbon? Can't he just make the 4 elements and decide how they operate? You know,
Well, carbon
there's a
is
lot
amazing.
of that, right?
You
What's
know,
that?
carbon is amazing. There's like 29,000 or whatever ways it can form molecules, where other things like silicon could be a substitute. It could be a silicon universe, but it's not as strong as carbon. And, you know,
yeah, there are, for people who are interested, that was a nice reference. Yeah, there's the silicone biology. There's been some good papers lately on the possibility of that. But I mean, really, it's just going to be what the most efficient thing by random chance is going to be the thing, right? So if silicon was better, we'd be silicon, right? Like that's basically how that works. So the point being is that God doesn't really doesn't perform well as an explanation for the odd things that we observe. The absence of God, however, performs very well as an explanation for the
well, and I get you on that, because like I asked Buzz with Hugh Ross's thing, Reasons to Believe, if man is God's crowning achievement, why wait 99% of the time for us to be evolved from the common ancestor, us and chimps? So like the Cambrian 550 million years ago, it's like that's the discovery people and intelligent design people say, well, there's proof of God because you have the arthropods, the echinoderms, the chordates like us, that this is really complex body structures that just suddenly kind of appear. You do have some ediacaran precursors, but doesn't that kind of point to God?
It might, if it actually was an explosion, but it's not. It took 80
it's like 10 million
years. Yeah. Right. Also, that's another example of what I'm pointing out. What happened with the Cambrian explosion was, if you follow the history of life, you're going from single cells to more complex single cells, and then to multicellular organisms that are not tissue differentiated, so like algae and stromatolites and things like that. And then something happened. It might, you have the mitochondria, you have a further thing. Something happened that allowed the possibility. Really, it's the ability to put methyl groups onto genes to turn genes off. And so that's what allows like an algae to actually change the tissues. So now it's not just all algae. Now it can have bones, muscles, eyes, and so on, neurons, and so on. So each cell in this cell colony, because we really are just giant bacteria colonies, right? We're just a pile of cells, and we would just be it would just be a bacteria colony, but for the evolution of tissue differentiation, which allows our different cells to become different things, skin and neurons and so on. Now, once that happened, I've got bones and things like that. And once that happens, what happened is you see over tens of millions of years is you see an explosion of random bullshit, right? Like just all kinds of wackadoo life forms, most of which were really bad designs, right? Because it's just random shit, right? Most of which
pretty random,
terrible.
kind of weird.
Yeah. Well, it all got wiped out except for the most efficient forms.
Oh, that's another problem. Yeah.
Evolution, right? So that's why we're, like you said, chordates, right? Like that's the thing. And like even the few like holdouts, the weirdos like starfish and stuff like that, like they're not taking over the planet for a reason, right? Like there are certain efficiencies of design that were much more effective, and they just got selected by that fact that they were more efficient. There's no intelligent person doing the selecting. It's just nature killing off the weak guys, right? So that's the Cambrian explosion is a perfect example of it. It's just chaos. Like nature just throws a bunch of random unintelligent chaos at it and just lets everything die off until the best stuff is left over. That's not intelligent, right? That's evidence of the absence of intelligence. That's exactly how a universe looks and how it builds to people like us.
But here's the thing, let me give you another example. Dinosaurs, real quick. Dinosaurs 220 million years ago, then they die out 65 million years. You got the Permian extinction. So why create things just to have but are we outguessing God? Are we outthinking God here?
Yeah, once you ask that, you're admitting that the theory is bad, right? Like,
well, so that's obvious. Yeah.
Yeah. What I'm saying is that your theory doesn't explain it, right? So God theory doesn't explain it. So you can't say like, well, maybe I could sit here and come up with something from the armchair, but you don't have any evidence that that's true, right? So like the thing is like it should automatically come out, like the results should actually automatically come out of your theory. It shouldn't be in tension with your theory. And so if you start without God, then evolution, the whole evidence of evolution of the last 4 billion years is not in tension with that theory. It's exactly what we expect to observe. So there's no tension there to explain. Whereas, if you're trying to explain why would God do it that way, well, now you have tension. Now you've got a problem. Your theory is not actually predicting the evidence. And so you're trying to say, well, maybe we don't understand God. It's like, well, then you don't know that it's true either. Like if you can't come up with a working theory that actually predicts things, and even if you do come up with one, if you can't present any evidence that that's the correct theory as opposed to other theories, then you're kind of in the weeds and you can't really get there. And so trying to make excuses for God isn't the correct way to go. Like that's why that never works in science, right? You can't keep a theory alive by continually making up excuses for why it doesn't work. The theory needs to work, right? Like that's what makes it likely.
Well, my thing is live with the tension, So what were you saying, Kelly?
Oh, there's a couple of comments and questions that I want to get to. One is a comment from way back at the beginning of the show that I thought was quite good from Joel Pearson. If the point of positing a creator is to explain complexity, you've just made the problem worse and explained nothing, because now you have to explain something much more complex than a universe. And Dr. Carey, I think that's kind of what you went into after that.
Yeah, I'll play devil's advocate though. And by the way, hello, Joel.
Oh, thanks, Dr. Carey.
I'll play devil's advocate there and then point out, and theists are chomping at the bit, I'm sure, to say, oh, but we have all these arguments that God is a super simple theory, right? So that's the usual path there. That doesn't work out. By the terms of theory complexity, God is not a simple theory. None of Swinburne's arguments, none of those work to actually get you to an actually proper, in terms of probability theory, an actual simple hypothesis. So Joel's point is correct, right? Ultimately, but I do know what the maneuvers are, like what the rabbit hole of argument would be from there if theists were to press that issue. I also know where that rabbit hole ends because I've already gotten there, and it doesn't work out for the theists. But you can chase your tail on that for a while before you start to realize that what Joel's saying is correct, right? Like God is too complex a theory. Whereas simple quantum vacuum is much more likely to be true because it's vastly simpler. It has way fewer free parameters and way fewer presuppositions, and the entities that we're proposing are super simple in terms of theoretical structure. Like there's no supermind, there's no superpowers, right? So there's no complexity of that scale going on with those theories.
But if God's behind it all, doesn't it all fall into place? By the way, did you find anything Luke Barnes said? You've read some of his stuff, compelling?
No, I have a problem with Luke Barnes, actually, and people can rabbit hole that. I've dealt with him before. I'm not entirely sure that he argues in good faith. I feel like he hides things from people, misrepresents evidence and things like that. But that's been my experience, and so I don't trust Luke Barnes, is to put it that way. But even if I did, when you look at the statistics, you actually look at polling. We've done this, polled physicists. Only 3% are with Barnes. So interestingly, most physicists, like over 40% of physicists, think that fine-tuning is explained by some form of brute fact, so what we call inevitable physics explanation. So more physicists think that than think multiverse theory explains it. And multiverse theory is a pretty good theory for explaining.
Well, I do agree. Like we've had Michael Strauss on, who works at CERN, teaches at University of Oklahoma, and he gives amazing arguments that seem to point to God. But when these guys get in trouble is when they try to when they try to get Genesis to go support the science. And that's when they all get in trouble.
That does create problems. That's why I think more fruitful discussion can occur with someone who's not, shall we say, shackled to having to defend that kind of absurd position. I'll admit that there are far more plausible God theories than any existing major religion proposes, right? And so I think if you are going to go with God, you really have to go with something way weirder than Christianity or Islam or any of those things. Like they're clearly wrong. In terms of how none of their theories make sense of any of the data. So it's got to be a way weirder. Like a God who's totally there was the joke of the botanist. I'm sorry, not the botanist. The biologist who said, who referenced God's inordinate fondness for beetles, so that maybe because there's more diverse species of beetle than any, and they've lasted longer than almost any other animal on the planet. And so like maybe God actually built the world for beetles, and we're just a accident. But like we're basically just the poop of the beetles, and we just exist to serve the ecosystem of the beetles. And like maybe, right, like that would explain a lot more things, right? It would explain why God doesn't care about our welfare, and why and why he experimented so much, and
well, they do these exegetical gymnastics to go and get the Bible right, and it just admit, they got the earth and sun order wrong, and it wasn't translucent, became transparent. And that Luke Barnes says, we had him on, and he said, oh, well, I don't believe in this tinkering God. And I'm thinking, well, wait a minute. He's got to step in for the Cambrian. He's got to step in to get the carbon off the ground. It's just too complex for beryllium, which just lasts a split second, to have these two heliums, form beryllium and carbon. I just would seem to think that he has to step in a lot, wouldn't you?
Yeah. Right. like in terms of this gets back to my Ingersoll point about the fabulous carriage. It's just not how an intelligent engineer would build, right? Like you would expect something. So it's like you took Paley's argument with the watch, right? You find the watch, oh, something intelligent had to build that, right? But now instead of the watch, what you find is a machine the size of a city filled with 1 trillion to the power of 1 billion gears, and all it does is the same thing as the watch. And would you say like that's intelligent? No, that looks like, and it's not even like organized gears. It's just really hinky craziness. You think it's just like a bunch of, like a lunatic built it. It's not.
But when I was an atheist, it seemed like I was, trying to do God's job. And I thought that job position was filled, I mean.
Right.
When I was in high school, there were a group of boys that would always put up the quote of the day. And one of them was very along the lines of what you were talking about, Dr. Carrier. And this was my favorite one. I have remembered it already all the way back since high school, which is human beings are an invention of water to facilitate its movement from place to place.
Yeah, that's a good one. Another one, of course, is Smolin's theory that God is actually, he likes black holes. Because you can show that this universe is more efficient at generating black holes than generating people, right? So maybe we are literally just fleas in the ointment, and really God is all just fascinated with making black holes. But yeah, you could go speculate. But the point being is that these sort of joke models do actually explain more data, which is why real God theories are worse than even the joke theories. In terms of explanatory power. So yeah, that's the problem that I have. And anyway, okay. In terms of time, do we want to take comments from the audience? Or
well, I've got 2 more questions that I was planning to get to, and then I was going to wrap things up. But I promised Daniel Ray that we would get to a couple of these questions because he has posted numerous questions. But I did select 2 of them for us to actually address. And the first one is, matter, energy, plasma, inflatons, none of those can be eternal because it undergoes change and decay.
Yeah, I mean, this is answered in the actual science. So you can go into why eternal inflation is eternal. Change can be eternal. Like you can have a coin flip from heads to tails infinite amount of times. So you can have eternal change. And decay is actually one of the things that keeps eternal inflation going. So it actually drives the ecosystem of internal inflation. So in terms of the physics, physicists have already worked that out. So like that's not a problem.
Isn't nuclear decay an example of eternal decay?
In terms of like higher levels of matter, right? So like for instance, like there's a debate whether protons decay, right? Maybe they do, maybe they don't. If they do, they take forever to do it. But atoms can, because atoms are complicated. They're like these complicated machines that fall apart basically if they get too much stuff, too many gears in there. It's a messy design, right? But of course, what happens to that stuff is that it recombines somewhere else. It ends up something else. And so in terms of like eternal inflation, what you have is these bubbles The bubbles themselves decay, like they become, their entropy just goes to, to equilibrium and so on. And you basically just end up like a giant sphere full of gamma rays or something like that. Now, you have also things like the Carroll-Chen model where, maybe you have this bubble decays. Now, of course, in the eternal inflation, it's constant bubbles. And the reason is because chance accident inevitably results in a bubble. And the Carroll-Chen model is an example of this, where they calculate the probability of, through just quantum randomness, just quantum accident, the probability of a spontaneous Big Bang. Now, if you average over time, like you would have entropy increases, but you have forever, you will always have Big Bangs, because once the space-time's there, it just sticks around. You're constantly rolling the dice in terms of quantum fields, right? In terms of, so that eventually, no matter how improbable a Big Bang is, on an infinite timeline, all probabilities approach 100%. This is a basic principle of probability theory. So eventually you're going to get another Big Bang, and then you sit around forever and ever. Eventually you're going to get another one, like just out of random chance, because that's just how random chance works. And a lot of physics actually generates a lot of order and structure out of just like the positing randomness. Random phenomena is extremely powerful. That's what drives evolution, for example, without intelligence. Randomness is fundamental to the success of evolution, to outcompete intelligent engineers and things. So it's the same thing with like atoms and space-times. And earlier was mentioned Penrose's theory of conformal cosmic cycling.
Cyclical conformal cosmology.
Yeah, right. Thank you. Say it again so people hear it correctly.
Cyclical conformal cosmology.
That's an example where what he posits is that once all the matter has decayed, so he is assuming protons decay. That's one of the criticisms of the argument, is we don't know that yet, but let's just assume he's right.
The dead charcoal is what he says. It's
also requires electrons to decay. That's another. But if we assume all matter decays, and if that's the case, then he has a model that works where eventually you get statistically you get a reset. So that perfect equilibrium of our universe looks exactly like a Big Bang in another universe, so that our Big Bang might just be the end of one of those long aeons. And so you can do this all without intelligent engineering. It's just, and it's actually reliant on decay. Decay is actually what drives the process. So anyway, that's my answer to that question. There's a million rabbit holes one can dive down in that. And it's all being explored in the physics. So like in the journals, cosmology journals, they're talking about this stuff. They're doing it. So.
Okay, one last question and we'll wrap it up. What constitutes evidence of other minds?
Ooh, that's a whole other show, right? Yeah. Well, okay, remember what I said earlier, like whenever you run into a question like this, you should ask, well, how would it be any other way? Like what would we have to change for it to be the other way around? So like if there weren't other minds, then what would have to exist to explain the information that we have? Like the fact that we're having this conversation right now. Am I hallucinating? Am I just the only person who exists in the universe and I'm hallucinating this? And so I'm hallucinating Kelly, I'm hallucinating our guest. It's just like, is that a good model? And so you go to like theoretical complexity. Actually, the hallucination model is much more theoretically problematic. So it has what you would call too much fine tuning in a different sense than we're talking about here. Physicists talk about fine tuning in terms of how much you have to tune a theory to fit the evidence. So it's not about habitability, it's about theory fit to evidence. If you have to hugely tune the theory to fit the evidence, it's a bad theory. The theoretical complexity goes way up, and so it's the least likely explanation of what's going on. So the question is, am I hallucinating is really the general question. And there can be micro circumstances where the evidence will bear out that it's more likely you're hallucinating. But when you have massive long data streams like I'm experiencing right now, at the end of the day and so forth, the probability that I'm hallucinating it's very low, and I can show that based on how much theoretical complexity I would need to explain such a sustained hallucination of such specificity, and also that I don't control and so on. And so that's how we get to theory of other minds, right? Is like, what is the better explanation? It's similar to like physics, like how do I know that my mind is not subconsciously creating the world? How do I know that there are even our laws of physics, right? Like that kind of thing. It comes down to what is the better explanation of what I'm observing. And usually in terms of theoretical simplicity, an external world is a better explanation of what's going on. And you can imagine scenarios where it wouldn't be. And like, there's a ton of Philip K. Dick novels that explore this, right? In terms of like, what would it take for you to have enough evidence to start suspecting that you are hallucinating, or that something isn't real that you thought was real, and so on.
Hey, I had a last question for Dr. Carrier.
Yeah.
You know, you're the expert in Jesus scholarship, and that's your background. Has this been a breath of fresh air? And to you, Kelly, also, this physics and learning all this new stuff, has it been fun for you? How do you feel about both of them?
I love doing philosophy more. I'm not asked to do philosophy as much as I'm asked to do history. I like both fields, don't get me wrong. But I do like doing history. I like doing philosophy. I especially like doing stuff in philosophy that people don't usually do. But which would be like actual atheist philosophy, where we're not debating theism. We're actually talking about, well, what is true? If we just assume the God question settled in the negative, then how do we explain qualia, like the nature of consciousness, the qualitative experience, and so on, like that? That's a really good and interesting question by itself. It doesn't have to be part of a God debate. And so I like doing stuff like that. And I have articles on things like this on my blog.
I know, Kelly, you've had Kelsey on and you've talked to a lot of, have you enjoyed this?
I do, but it also makes me feel stupid.
We'll join the club.
It takes a lot, right? So that's why I feel like I feel like I'm under-explaining things here and probably confusing more than enlightening. And because there's so much to unpack on everything, right? Like one single sentence is like pages of background information that you kind of have to get there. And it took, decades for me to get where I am. So I understand, like, it's hard to be just thrown in the deep end and like, oh God, what do you do here?
Oh yeah.
And that's why I hope, like, I try to encourage people to go out and get that back knowledge. Like, there are my articles that have a lot of that, and they have links that'll send you in, but there's also tons that you can just do yourself. Like I do encourage people to try, like, set a day, like just a day for you to understand cork gluon theory. And like, just go through it, and just to get to the point where you can at least sort of have a sense of it.
Well, we all have
because it's enlightening. Is the point. I think
we all have the layman's dilemma where we're all treading water here. Where you have to rely on experts that know the math, know the all the details. So, but I guess you get tired of talking about Jesus all the time, don't you?
No, yeah.
Golly.
Yeah. I don't get so tired that I never want to do it again. But yeah, I would like to spread it out a little, right?
Yeah. Well, this has been something really interesting, and thanks for chatting with us.
Yeah, thanks. It's been good.
Yeah, thanks for coming, Bill. Thanks for coming, Dr. Carrier. I hope both of you had a good conversation, and I hope everyone learned something, including the audience. Thank you so much for your comments and questions as well. Bill, is there anything you wanted to say in closing?
Well, just thanks for all the insight and for the study, and I'm glad this is new for us, because our thing is studying the Q and all these things, Jesus scholarship, and this is really exciting. So hopefully we can talk about Jesus. It's so much simpler, isn't it?
Yes, it is. It is much simpler. Okay.
Like I heard you, Kelly, talk about endogenous retroviruses, and just to get the name right is which terrible evidence against. Okay, I'll quit there.
Okay. Yeah, and thank you so much for Dr. Carrier for coming. Don't forget, there is a link in the description to Dr. Carrier's webpage. Go and visit that, and you can find all kinds of resources. And don't forget, Dr. Carrier will be live in Nashville for a debate if you would like to meet him in person. Okay, and thank you everyone for coming, and live your life.